Thanks everybody for joining me again here for another episode. I'm Brendan here at Just Plain Crazy. Let's check out all of the cool things going on in this giant Scale Zero. It's a Seagull Models ARF that I picked up over at Gator-Rc. Let's check out the neat stuff on the inside. Again, we're running a Jetty duplex system in this. We actually have a 2.4 megahertz receiver there, and we are running the 900 megahertz backup. You can see all of our antennas are all 90 degrees from each other, kind of separated at some different levels. This is a 10-channel receiver. We are actually running an SE6 way down there, that blinky light on the inside. So we're actually running 14 current channels. We have a splitter telemetry module in there where we're running 3 different pieces of telemetry in there, RPM, and 2 different cylinder head temperatures. We have our Voltario T60 battery backup system in there. So we have 2 LiFi receiver batteries. We have a 3-cell LiPo in here, 1000 milliamp for the auto start with the relay. You could see down on the inside our JP retract controller as well. And pretty much, well, we're going to cover the tank here in the episode. We have our throttle servo and our choke servo, which is on a delay. So that way, as you're auto cranking this thing over, you can actually, if the engine's warm, it'll hit right away because I mix the choke and that auto start together. If it cranks for more than 2 seconds, the choke will come in and close. So that way it kind of minimizes channel use. But anyway, stick around. You guys are going to see how to install all this cool stuff. Now that we have the wing completed, they want you to go ahead and get started with building the tank and setting in the engine and getting all of that placement stuff done. Here's the problem with doing that. And although you can do it in work, you're going to wind up with a big heavy anchor on the front of this plane, and it's hard to deal with always wanting to fall off, roll around on the bench and things like that. I prefer to get my tail stuff set up first. So we are going to go ahead and bypass getting the nose of this plane done and hop on over to, those are the electric instructions. So we are going to hop over here in the instruction manual to this part where we're going to go ahead and install the vertical stabilizer. So vertical and horizontal will be up next on the fuselage. We're going to get everything here test fit, make sure that everything is good to go. And then we are going to move on to the install. That will help counter off some of that weight up front. So here's the beauty of working with balsa. These planes are mass produced and it's balsa wood. So not everything is going to be perfect all the time. Doesn't mean it's bad. It means that we need to be creative. And this one's taken me a while to figure out how I'm going to fix this. Let me show you what I'm working with. As we get to this fuselage, I like to fit everything and make sure it all fits nice. I got the right side horizontal stab that fits in there perfectly. And then I have this horizontal stab that does this. It hits the side of the fuselage. So you're curious as to, okay, so something has an issue. What here is misbuilt? Because obviously something has an issue. And if you look here at my pencil line all the way underneath, you're about 1/8 of an inch that would need to be trimmed here, which means that you're going to drop down and create 1/8 of an inch gap up there, and it's going to be undesirable at best. Now, you can cover that up because the fillet's going to be over it, but still that tells me something's not aligned. And it could be the simple side of the fuselage sheeting that's off, or it could be the wing tube and the horizontal stab. So what I did is I leveled this off. Always use a center line stringer for a reference point from there back into here. I used a string with a piece of tape, as I always do, to find symmetry between side to side, and this thing works great. And I went over to the other side, and here's what I found. This side sat up, this side was sitting down. That's the reason that this is hitting there. So by just grinding that out and getting it to fit was going to have to be offset with aileron as you fly. It's not going to make for a great flying plane. And it took me a while to debate what I wanted to do here to fix this. So ultimately what I did is I took my Dremel tool and I buzzed around that socket for the wing tube. And what I noticed now that I have that play up in the inside is that it also dropped this side down, because that's what I found was this side was high, this side was low. So by fixing my problem here, I also fixed that problem over there. I can access the underside of that tube through the tail wheel hole, And all we're going to do is I'm going to set the stab in, make sure that everything is perfectly level and perpendicular to here, and then I am going to fill the underside of this socket in with epoxy and let that stuff harden into place, and it will be just as good as if it was just solid wood. But these are small changes. We got to work through these things. This is, you know, part of building. There's no instructions for this stuff. You have to be a modeler and recognize when something isn't right, and this one took me a little bit to figure it out as far as what I wanted to do, but we're heading in the right direction, so let's get the tail on. The next couple steps are going to require the use of a lot of epoxy, so the wife is going to love me when we stink the house up. She yells at me, "That hypoxy stuff stinks." So we try and limit it. But anyway, we have these 3 covers right now that we're going to, these fillets, if you will. We're going to have to cut out all 3 of these. Now, they do show you using a pair of scissors, but if you don't have a pair of Lexan or Lexon, however you want to say it, scissors for cutting like out RC car bodies and plastics, they're curved. These things work phenomenal. But what you want to do is go ahead and trim these out all the way around. We are going to fit them over the rudder and the openings for the horizontal stabs. We are going to take our stabilizers. Remember, do not get the flaps mixed up one side to the other. Keep them in the set. We've already gone ahead and ironed all of our covering flat. We're going to do the same thing with the horn installs that we've done in the past, as well as CA in the hinges. So there's a lot of gluing and setup that needs to go into the tail, but we're already kind of, everything's out and we're ready to go. Let's get this stuff all put together. Now, there are some things to actually note in this step and be very, very careful of to prevent ruining your model. These fillets, once they're cut out, be very careful that you don't cut into the horizontal stabilizer area there. They give you a reference mark, and I'm actually about 3/16, maybe a 1/4 inch past where they gave me in order to make that fit. But you want to go install your horizontal stabs first, then make sure that this thing comes and it fits over nice and snug. You don't want to trim off any more than you need to in order to get a nice clean edge there. For the top, you're going to wind up cutting the back of this off, so this thing will fit around here, but you need to cut that off so that way you have room for this rudder to actually sit all the way down on top of the fuselage. Once we tape this down and we glue it, we're simply going to use painter's tape, and again, we're going to use the clear canopy glue that I always use. This stuff, that will work great. And a little tip here for like things like this edge, if you just heat that up with a heat gun a little bit afterwards, just a little bit of heat, you can work those seams in and it'll look pretty flawless all the way around. If you take a sanding bar as well to all of those edges here, you can help to fine tune the ripples so you don't have this effect going all the way around. But it's time to go ahead and get these installed first, and then we're going to be doing all the hinging. So let's go. Once again, we have our elevators positioned in the neutral position, and we have them held. We used our laser to set in our horns. We used the tape to create the fillets, and we know that those horn openings are exactly on the hinge line for rudder, for both elevators, and are as symmetrical side to side, and that'll give you neutral this way and this way, so you don't have more throw one way than the other from being off of the hinge line. So we're going to let this sit up for the next hour and a half or so, and we'll wind up coming down. I don't like to disturb and bang the model around with those things. They're curing. We'll give it about a half an hour. We'll pull the tape, and then it needs at least a full hour to go ahead and cure. Again, our plastic fillets here, we took the tape off. They turned out really nice. Make sure that if you have any bubbled edges, just take a heat gun, heat it up, a little bit of pressure, and that stuff will re-stick and be absolutely perfect. And remember, everything is symmetrical side to side, so you have to make sure you get the right and the left sides together, or when you put this elevator on there, it winds up being a huge difference from this fillet on the side. But anyway, let's let this set up and we'll get back to it. Now by preference, we have the motor hung on the front, so we're going to start to now counterbalance a little bit more weight to the back. Again, my building preference. We're going to come back into the manual now, where it shows you how to put the tail wheel in the plane. I've seen a lot of posts and concerns on different forums, Facebook, YouTube, or whatever, that this tail wheel is essentially only held in, which almost every nose gear from the time planes were started, that they were started to be built, all the nose gears are held in with the exact same design, and it's no different. Instead of this being a tail wheel, this was the nose wheel. So panic not, this design has been around for ages, and I've had no issues with it. But for the sake of this cover being glued on with canopy glue on the inside there, and we're never going to see this again, the fix here, guys, is really simple. All I did was flat spot the top of this thing, and I got myself just a random wheel collar that I had in my stash, and I'm going to just go ahead and tighten that down at the top. And once this is bolted in, there's no way that this screw is going to back out and this screw would back out and allow this thing to fall. This is a super strong, robust tail wheel. I think it looks pretty neat on this size model. I don't know how it would be on others or exactly what other models use this, but pretty nice job on the flexible, robust gear here. But we're going to go ahead. There's a flat spot for the arm to center that. We're going to put our collar up at the top and tighten it. We are actually going to use lock washers on our screws that we're going to put in there. And then all of those things, we are going to just put a small dab of Loctite, very, very small dab. And we're going to get that thing mounted up in there. Let's get to it. It's time. We're going to go ahead and install now the elevator and rudder servos. Again, we're going to tap them through, soak them full of CA, and get all of those servos in and get them rough mounted up so we can start securing some linkage and start getting ready to route that receiver wiring. All right, guys, in this step, we've now gone ahead and bound. This is our 2.4 receiver that we are going to be running on the inside. And on this model, I am also going to be running a satellite 900 NG. So what this is actually on a 900 megahertz channel. And if we ever lose 2.4, which is already doubtful, this thing will automatically pick up on the 900 megahertz frequency and alert me or let me know. But these things are so rock solid, the only thing that this is in there for is really peace of mind. I doubt we will ever even need it, but also we are going to use the channel expander capability out of the bottom of this thing as well. So we're going to need that. Could have gone with a 12 channel receiver here with all this other stuff, but for now we're going to see if we can make this 10 work. So the receiver, the 900's bound, the 2.4 is bound. We'll set that off to the side. Let's talk about servos. The right way to set stuff up. Now this one's going to be slightly different, and I'm going to use my rudder here for an example. So I've done a rough fit and adjustment here of the rudder. Now, these are digital, non-programmable servos. So this is the King Max servos that we went with in here, the 5523, I believe is what they were. And you notice the arms fit, so we're kind of off center here a little bit. And you can't really get another arm and position it there in order to straighten those out. So ultimately what you're going to have is one throw further than the other, and you don't want to leave them this way and then try and adjust it out of all your linkage. So what we are going to do is go down into our sub trim menu, and I am going to go ahead and adjust that sub trim menu till I get that arm in there straightened out. And then that is going to be what I consider my neutral position. So we should have the same amount of throw one way or another. Now we are not going to go to the end of the limits with this. Keep in mind, the further you go out with the servo, the more throw you are going to get, but also the less torque you have. So the more torque will come from being closer to center, but the further this arm has to move, the more servo resolution you are going to get. So if you have a good radio and a good set of servos, you actually want that thing to actually have all that movement in there. You don't just want to use a couple steps of that resolution, you want to use all of it, and it makes it a better feel or a better handling plane. So we've gone ahead and centered this. I started with my linkage way out here and I had way too much throw. So we're checking right now on the max total throw, and you can see I'm using my throw meter here, and what was happening, the spec on this is only 30 high rate and 20 low rate. I was actually way out here at the 50 when I was checking my throw on the outer edge of that servo arm. I put them all the way at the inner edge, and now you can see, let me grab my radio here. And now you can see this would be our high rate spec. Right now I'm coming in at a little over 35 there and 40 here. So that's still using that max adjustment, and we're off with the sub trim. But what will happen is I'm going to limit this on the high rate to 30 there and 30 there, and that will maximize my resolution with these non-programmable servos. Again, you can go with programmable if you want to, but again, there's not always the need for that, and it's also budget dependent. So here we have a good amount of throw in both directions, and I can fine tune it, and I'm getting the most amount of resolution possible right now in my setup. Okay, so let's go on the inside and take a look at our elevators. So we have elevators that are exactly the same setup as well. So I've used the sub trim and we've centered those, and I went to the outside edge of those holes, which actually keeps my linkage rods lined up, and that gave me within my limits of throw. So I'm pretty close right there using the outer hole. Those are probably 1-inch arms if I had to guess without measuring, and I'm still at the edges of where I want to be max throw wise, so that's perfect. So when we go to dial down, we don't have to dial down much, and I am getting the most amount of resolution possible out of these servos. And the other thing that you're doing by using sub trim to perfectly center these is you're actually going to get even throws across the back, since we can't synchronize those in this setup. Otherwise, After this is centered and those are centered, now you're going to come out here to your linkage and adjust on your servo horns until you get this piece centered up and also here centered up the way you want to. So let's get to some mechanical adjustments and start to finalize some of the linkage in this plane. We're going to go ahead and open up, we just received our telemetry expander and the temperature sensors that I'm going to be using in this model. So we're going to open those up. I'll show you guys what those look like. So this is pretty simple. You can run as many of these as you want to with as many different extra pieces of telemetry. And basically this is just a telemetry expander that's going to plug into the telemetry port on the receiver. And then this is going to be our temp sensor. So within our temp sensor we can actually put 2 probes out there on the engine. So if you want to, realistically, you can mount these. These are not your typical just kind of stick on something ones. These are made to wrap around, in this case the cylinder head, and then you use the little silicone tubing here at the bottom to draw these tight around the engine, and the thermistor, the temp sensor, is actually in the middle. So I can use these to measure if I wanted to around the crankcase or around the cylinder head. Usually 2 to 205 degrees is where you want to keep most of your engines. Maybe each engine manufacturer has something a little bit more specific, but if you stay at that 200 temp range, you're usually going to be just fine. And the other thing that you can actually do with one of these, if you wanted to, is you could actually just leave one inside the cowl. So if you wanted to know what ambient temperature is, or if you wanted to wrap it around a battery or something like that, you may do that as well. But just different things that you can do with these loops, but they're best used to wrap around something that's obviously not a spinning component. So let's go ahead and get this stuff mounted up. I've been waiting for this, and this will help me to finish up my wiring here towards the front of this EME. Let's get to it. So now we're going to get this choke servo set up, and the goal is here is we don't want binding in either direction. So when this thing is either fully open or fully closed, the servo's not humming, chattering, drawing excessive current, trying to burn itself out, and constantly fighting a mechanical linkage the whole time. You want them to mate perfect together. And how we are going to do that, we are going to come into, here's our choke setup right there. I have it right now just mounted on a 3-way switch, but I'm going to be taking that off when I'm done setting it up, and I'm actually going to put it on my auto start button. So whenever I have the button held down for auto start, the choke will automatically close for me as well. Now, you can watch the arm and the linkage, but what I like to actually watch is that lever right there. So when we come down here to the radio, we have the thing into a fully closed state. You can see at the top of my radio hopefully up there you see the little bar goes one way, so I know I need to come down. That's going to be my negative number. And basically what I am going to do is set this endpoint, number 1 by watching, 2 by listening, so you can actually see we still have movement, have movement, have movement, have movement. And there you start to hear it hum. It's too tight. So we're just going to keep backing it off. Notice it's not moving yet. And right there I started to get the first movement. So we're going to come in. Right there is going to be my fully closed state. We're going to come back in here to open. And we're going to select that. And now I'm going to do the same thing the other direction. So we're going to keep moving it until we see that arm stop. And again, you'll hear it start whining and go back enough right there. So now we're fully open, fully closed, and adjusted. And if you want to get rid of any extra hum in this thing, you can simply back it out till it's not making any noise, or try and use sub trim to dial that out as well. So I like where that sounds right there. I think that's going to be perfect for us. All right. Now we're going to do the same thing with our throttle servo. So we're going to back out. We're going to come into throttle right there. And again, looking down here at our radio. So you have a full wide open throttle there. And we're going to come to a closed throttle. Now what I like to do in throttle setups is I'm actually going to go up a couple notches from middle with trim, so that way I have room to come down open and closed. And at full closed, we're going to come over here and we are going to look at, now there's a lever, if you can see it right there. We are going to be watching that lever until that lever stops moving. There. And then as we go open, you can see that there's a mechanical stop in there against the edge, and that one's easy. That's our wide open stop. And we adjust there until that thing hits. Right there. So then we should have fully open, fully open right there, fully closed right there with no real binding or noise in between. Take just a hair out. And that's going to be about perfect. And then we have our choke. All right, guys, and that's how you set up your throttle and choke servos. Now we're going to mix that over to there. We're going to install the vent line, and it is time to clean up the wiring and mount this. Once the receiver's mounted in, then I'm going to go ahead and route in and mount my 900 as well as my backup. And I think it's time to get some wing wiring done, and we're getting pretty close to putting some nice finishing touches here on our Zero. And don't forget these cowling, real quick here with these adjustment screws. There's a lot of people that love to just take the throttle stop out altogether as far as a minimum idle. I'm not completely opposed to that one way or another. I don't think it really matters. It's just one of those things. You can leave it in or leave it out. It's your preference. And also here with your high and low needles, instead of marking the cowling I'm going to show you a cool trick where we can come in and trim that cowling perfectly with those once we have everything adjusted. I'm not even going to worry about the cowl until the motor is adjusted in. This thing actually recommends 91 through 93 octane and a 30 to 35 to 1 air to fuel ratio, or oil to fuel mix. So I will actually show you guys, if you've never done that before, how we go ahead and mix it. But here is a tip for you, high and low. What I do is I come over here on my platforms and I will just take a Sharpie and write high, and it goes in the back, low is in the front, and now I always know which one of those two holes is which one without writing on the cowling and maintaining some of that clean look. So let's get to installing our vent and electronics. Let's go. All right, here you go. Check it out. So this is our sneak peek of what's going on in the inside. We have our LED for ignition armed indicator. We're running a Rex 10 receiver with a 900 megahertz backup. So a completely different frequency. Should this one get dirty, it'll automatically flip over to there. We are running a Voltario, and you can see that hopefully right up in the inside right there. That is a battery backup system, so it will automatically switch between my two receiver packs and monitor voltage in case of failure or one getting low. We have our battery for our auto start in there. The choke is hooked up, so it is actually mixed into here. So as soon as we activate the auto start, the choke will close and start the engine. Again, our throttle servo. Here is our digital thumbprint, so it uses the temperature to make contact of our thumb to actually turn on the system and arm it. In the inside, we have our ignition. If you can see down in there, there's our electronic ignition shut off. There is our JP retract controller and our SE6 serial expander, because we're only running a 10 channel receiver but actually 14 total channels with all of the bomb drop and ignition shut off and everything else we're running. Here is our tank all nice and mounted in there, and on the underside of the cowl, you can see our ignition is mounted in with our RJX strapping. Everything is in protective convolute. Our wiring for this side is run into our motor as well as our ignition module. We have protective coating over our secondary ignition wiring. That will get tucked in nicely once the cowl is installed. And then on this side, you have your ignition pickup, which is running into your ignition module, broken out into an RPM sensor going into the telemetry port. We actually use a 4-channel telemetry expander, and that's that little thing right down in the inside of there. And then we're also running 2 cylinder head temperatures, so an actual cylinder head temp and then a crankcase temp. So between A and B, I can monitor those, and exactly once I find where I want this vent tubing, we'll also get that put in place. So with that being said, that stuff looks awesome. We are getting closer to completion. We're really going to start to break into the wiring harnesses now, but what I want you guys to understand is everything that we covered here really fits into this zero very exactly, but these principles apply to anything that you want to do, balsa ARF or gas engines, composite planes. These techniques will carry through to all models. But of course, if you guys are interested in this really cool giant scale zero or many other balsa ARFs, I want you to go over to Gator-Rc, www.gator-rc.com. Check them out. They have lots of cool planes, lots of cool warbirds, huge selections, great prices, family-owned business. Just go over there and give them a shout out. Tell them Just Plain Crazy sent you. You know, check them out. Look at all the different cool things that they have to offer. Your one-stop hobby shop for sure. But again, I hope you guys are subscribed, like, share, comment down below if you love what we're doing here so far, and if it benefited you throughout this whole experience. I hope that it was of value. So if you liked it, make sure you give me a thumbs up. It helps the channel. If you didn't like it, make sure you hit that thumbs down button twice for me. Again, as I said, like, share, subscribe. Don't forget to hit up our merch store down below and also our Facebook and Instagram pages. With that being said, happy flights, guys. Peace out.